Hello students, welcome to this lecture 1 Probability and Statistics. So in this lecture we will discuss NCERT Exemplar problem 1 Statistics and Probability. Okay, so let us see first question here. So the millage kilometer per liter of 50 cars of the same model was tested by a manufacturer and details are tabulated as given below. Okay, so find the mean millage. The manufacturer claimed that the millage of model was 16 km per liter. Do you agree with the claim? Okay, so let us see the answer. So here, first of all, we make this table. Okay, here we calculated class marks xi and fy xi. Okay, so millage in kilometer per liter, they are given in this class interval, and class mark xi, that is calculated by using the formula lower limit plus upper limit divided by 2. Okay, and then number of cars that is denoted by fi, and then we calculated fi xi. So for this class 10 to 12, here class mark xi is 11 and number of car is 7. Okay, and then fi xi, this is equal to 7 into 11, that is equal to 77. Okay, and for this class 12 to 14, here class mark xi is 13 and number of car is 12, and here fi xi is equal to 156. And for this class 14 to 16, here class mark is 15 and number of car is 18, then fi xi is 270. And for this class, here the class mark xi is 17 and the number of car is 13, and then fi xi is 221. And now total number of cars is actually summation fi, and this is equal to here 50. And then summation fi xi, this is equal to 724. Okay, so from this table we get this to value. Summation fi, this is equal to 50, and summation fi xi is equal to 724. Okay, and we know the formula of mean, that is x bar, this is equal to summation fi xi divided by summation fi. Okay, and this is equal to 724 by 50, that is equal to 14.48. Hence mean millage is 14.48 km per liter. So the manufacturer is claiming millage 1.52 km per hour. That is more than the average millage. Okay, so the manufacturer claimed that the millage of model was 16 km per liter. So this claim is actually false claim. Okay, so now let us move to next problem. The next problem, here the following is the distribution of weights in kg of 40%. Okay, so we have given the data in this table, and we have to basically construct a cumulative frequency distribution of the less than type table for the data above. Okay, so let us construct a cumulative frequency distribution table for the data above. Okay, so here the cumulative frequency distribution less than type is shown in below. Okay, so here weight in kg less than 45, here cumulative frequency is 4, and when weight in kg is less than 50, the cumulative frequency is 4 plus 4, that is equal to 8. Okay, and when weight is less than 55, the cumulative frequency is 8 plus 13, that is equal to 21. Okay, and when weight in kg is less than 60, then cumulative frequency is 21 plus 5, that is equal to 26. Okay, and when the weight in kg is less than 65, then cumulative frequency is 26 plus 6, that is equal to 32. Okay, and when less than 70, then cumulative frequency is 32 plus 5, that is equal to 37. And when less than 75, then cumulative frequency is 37 plus 2, that is equal to 39. Okay, and then when less than 80, then cumulative frequency is 39 plus 1, that is equal to 40. So this is the table of cumulative frequency table. Okay, so this is actually cumulative frequency table. So now let us move to next problem. So in next problem, here we have given the following table. Shows the cumulative frequency distribution of marks 800 students in an examination. Okay, so construct a frequency distribution table for the data above. So we have given this. This is actually cumulative frequency table, and we need to find the table for frequency distribution. So let us construct. So here we observe that 10 students have scored marks below 10, that is it lies between class interval 0 to 10. Similarly, 50 students have scored marks below 20, so 50 minus 10, that is equal to 40 students lies in the interval 10 to 20, and so on. So the table of a frequency distribution for the given data is this. Okay, so here the class interval 0 to 10, here the number of students is 10, and for class interval 10 to 20, the number of students is 50 minus 10, that is 40. Okay, and for class interval 20 to 30, the number of students is 130 minus 50, that is equal to 80, and for class interval 30 to 40, here the number of students is equal to 27 minus 130, that is equal to 140. And when class interval for 40 to 50, here the number of students for 440 minus 270, that is equal to 170. Okay, and for this class, here the number of students 570 minus 440, that is equal to 130, and for this class the number of students 100, for this class the number of students 70, and for this class the number of students is 40, and for this class the number of students is 20. Okay, so this is the frequency distribution table. Okay, so now let us move to next problem. So in next problem, from the frequency distribution table, from the following data, here we need to construct the cumulative frequency distribution table. Okay, so let us here we observe that all 34 students have scored marks more than or equal to 0. Okay, and since 32 students have scored marks more than or equal to 10, so 34 minus 32, that is equal to 2 students lies in the interval 0 to 10, and so on. Now we construct the frequency distribution table. So here class interval 0 to 10, number of candidates 34 minus 32, that is 2. For class interval 10 to 20, number of candidates 32 minus 30, that is 2 also. Okay, and for class interval 20 to 30, number of candidates 30 minus 27, that is equal to 3. And for class interval 30 to 40, number of candidates 27 minus 23, that is equal to 4. Okay, and for class interval 40 to 50, number of candidates, this is actually 23 minus 17, that is equal to 6. Okay, for this class, number of candidates 4, and for this class, number of students 6. For this class, number of students 6, and for this class, number of students 5, and for this class, number of students 2, and for this class, number of students is 4. Okay, so this is actually frequency distribution table. So now let us move to next problem. So in next problem, we have to find the unknown entries A, B, C, D, E, and F in the following distribution of heights of students in a class. Okay, so here in this column we have height in centimeter, in this column we have frequency, and in this column we have cumulative frequency. Okay, and we need to find the unknown entries A, B, C, D, E, and F. Okay, so let us find. So let us see the answer. So here the here the cumulative height in centimeter. These are in class interval. Okay, and frequency is given to us, and cumulative frequency is given to us, and then when comparing last two tables, we get is here we comparing for these last two tables. Here we get A is equal to 12 and B is equal to 13. That is 12 plus B is equal to 25. That implies B is equal to 13. Okay, and 22 plus B, that is equal to C, and it implies C is equal to 22 plus 13, that is equal to 35. Okay, and 22 plus B plus D is equal to 43. It implies D is equal to 8, and 22 plus B plus D plus E, this is equal to 48, and it implies E is equal to 5, and from this equation we get the value of F. Okay, so basically here we calculate the frequency, cumulative frequency. Okay, and when comparing these two column, here we get the value of A, B, C, D, E, and F. Okay, so therefore the value of A is 12, B is 13, C is equal to 35, D is 8, and E is equal to 5, and F is equal to 50. So now let us move to next problem. So in next problem, the following are the ages of 300 patients getting medical treatment in a hospital on a particular day. Okay, so in this table we have given the ages of 300 patients that getting medical treatment, one a hospital. So from less than type cumulative frequency distribution and from more than type cumulative frequency distribution table. Okay, so here we observe that the number of patients which take medical treatment in a hospital on a particular day less than 10 is 0, and similarly less than 20 include the number of patients which take medical treatment from 0 to 10 as well as the number of patients which take medical treatment from 10 to 20. So the total number of patients less than 20 is 0 plus 60, that is equal to 60, and we say that the cumulative frequency of the class 10 to 20 is 60. Similarly for other class, okay, also we observe that while 300 patients which take medical treatments more than or equal to 10, since there are 60 patients which take medical treatment in the interval 10 to 20, this means that there are 300 minus 60, that is equal to 240 patients which take medical treatment more than or equal to 20. So continue in the same manner, then we get this table less than type when age in years less than 10, the number of students 0, less than 20, number of students 60, less than 30, number of students 102, less than 40, number of students 157. When age less than 50, the number of patients 227. When the age less than 60, number of patients 280. When the age less than 70, then the number of patients 300. And more than type table here, when age in year more than or equal to 10, then number of patients 300. When more than or equal to 20, then number of patients are 140, and then more than or equal to 30, then number of patients 198, and when more than or equal to 40, the number of patients 143, and more than or equal to 50, then number of patients 73, and more than or equal to 60, the number of patients 60. Okay, so these are two table of cumulative. These are cumulative frequency of distribution. Okay, so now let us move to next problem. So in next problem given below is a cumulative frequency distribution showing the marks secured by 50 students of a class. So here we have to form the frequency distribution table for the data. Okay, so here we observe that 17 students have scored marks below 20. That is, it lies between class interval 0 to 20, and 22 students have scored marks below 40. So 22 minus 17, that is 5 students lies in the class interval 20 to 40. And continue in the same manner, we get the complete frequency distribution table for the given data. So the marks when 0 to 20, the number of students 17. When marks in interval 22 to 40, the number of students 22 minus 17, that is equal to 5. And when marks 40 to 60, the number of students is 7. When marks 60 to 80, the number of students 8. And when marks 80 to 100, the number of students 50 minus 37, that is equal to 13. Okay, so this is the frequency distribution table. So now let us move to next problem. So in next problem here we have weekly income of 600 families is tabulated below. Okay, so here we have given the income of 600 families. Okay, so compute the median income. So let us see the answer. First we construct a cumulative frequency table. Okay, so for this class 0 to 1000, number of families are 250, and the cumulative frequency CF is 250. And for this class 1000 to 2000, this is actually mid class. Okay, and here the number of families is equal to 100 is equal to 5. Okay, and cumulative frequency is 250 plus 190 equal to 440. And for this class 2000 to 3000, number of families are 100, and cumulative frequency CF is equal to 440 plus 100, that is equal to 540. Okay, and for this class 3000 to 4000, number of families are 40, and cumulative frequency CF is equal to 540 plus 40, that is equal to 580. And for this class 4000 to 5000, the number of families are 15, and then cumulative frequency CF is equal to 580 plus 15, that is equal to 595. Okay, and for this class 5,000 to 6,000, here number of families are 5, and then the cumulative frequency equal to 5,595 plus 5, that is equal to 600. Okay, so this is the cumulative frequency table, and from this table here here's the total frequency n, this is equal to 600, and therefore n by 2, this is equal to 600 by 2, that is equal to 300. And since cumulative frequency 440, this lies in the interval 1000 to 2000, and this value is actually just more than 300. Okay, so here the here the lower limit of the median class L is equal to 1000, and F is equal to 190, CF is equal to 250, and class width H is equal to 1000, and total observation N is equal to 600. So therefore we know the formula of median, that is median is equal to L plus N by 2 minus CF by F into H. Okay, and now if we substitute the these values in this formula, then we get median is equal to 1000 plus 300 minus 250 by 190 into 1000, that is equal to 1000 plus 550 by 190 into 1000, and this is equal to 1000 plus 5000 by 19, and this is equal to 1000 plus 263.15. okay, and this is actually equal to 1263.15. Okay, hence the median income is rupees 1261.15. Okay, and now let us move to next problem. So in next problem, here we have the maximum bowling speeds in kilometer per hour of 33 players at a cricket coaching center are given as follows. Okay, and calculate the median bowling speed here. Okay, so here first we construct the cumulative frequency table. So here is speed in kilometer per hour we given in class interval 85 to 100, the number of players 11, and cumulative frequency is 11. And for this class 100 to 115, here number of players are 9, and the cumulative frequency is 11.9, this is equal to 20. Okay, and for this class 115 to 130, number of players is number of players are 8, and the cumulative frequency is 20 plus 8, that is equal to 28. Okay, and for this class 130 to 145, here the number of players are 5, and then cumulative frequency is 28 plus 5, that is 33. Okay, so it is given that n, that is actually total number of players, this is equal to 33. Okay, so here n is equal to 33, and therefore n by 2, this is equal to 33 by 2, that is equal to 16.5. So the median class is 100 to 115, where lower limit of the median class L is equal to 100, and frequency F, this is equal to 9, and cumulative frequency CF is equal to 11, and class width H is equal to 15. And we know the formula of median, that is L plus N by 2 minus CF by F into H, that is equal to 100 plus 16.5 minus 11 by 9, that into 15, and this is equal to 100 plus 5.5 into 15 by 2, 15 by 9. Okay, and this is equal to 100 plus 82.5 by 9, and this is equal to 100 plus 9.17, and this is equal to 109.17. Hence the median bowling speed is 109.17 kilometer per hour. Okay, and in question number 7, here the monthly income of 100 families are given as below. Okay, and this type of question we have solved in our previous slide. Okay, so you can check there and you can do it yourself. Okay, so this question actually I am giving to you as your homework problem. Okay, so now let us move to next problem, question number 18. So in question number 18, here the weight of the coffee in 70 packets are shown in the following table. Okay, so in this table we have given the weight of the coffee in 70 packets, and we need to determine the model weight of the packet. Okay, so here in the given data, the highest frequency is 26, which lies in the interval 201 to 202. So here the lower limit of the model class is 201, and frequency of the model class is 26, and frequency of the model preceding the model class is f1 is equal to 12, and frequency of the succeeding of the model class is f2 is equal to 20 and class with h is equal to 1. Okay, and we know the formula for mod, that is equal to mod is equal to L plus fm minus f1 divided by 2fm minus f1 minus f2 times h. Okay, and now if we substitute the values, L is equal to 201, fm is equal to 26, f1 is equal to 12, and f2 is equal to 20, and h is equal to 1 in this formula, then we get this is equal to 201 plus 26 minus 12 divided by 2 into 26 minus 12 minus 30 into 1, and this is equal to 201 plus 14 by 52 minus 32, and this is equal to 201 plus 14 by 20, and this is equal to 201 plus 0.7, and this is equal to 201.7 gram. Okay, hence the model weight is 201.7 gram. Now let us move to next problem. So in next problem, here we have two dice are drawn at the same time. Find the probability of getting same number on both sides, and find the probability of getting different number on both sides. Okay, so let us see the answer. So here two dice are drawn. Two dice are thrown at the same time. Okay, so total number of possible outcomes, this is equal to 36. Okay, so total number of possible outcome is 36, and we have same number on both sides. So possible outcomes are 1, 1, 2, 2, 3, 3, 4, 4, 5, 4, 5, 5, and 6, 6. Okay, so therefore number of possible outcomes, this is equal to 6, and then the probability of getting same number on both sides, this is equal to 6 by 36, that is equal to 1 by 6. Okay, now we have different number on both sides. Okay, so now number of possible outcomes, this is actually equal to 36 minus number of possible outcomes for same number on both sides. Okay, and that is equal to 36 minus 6, and this is equal to 30. So now the probability of getting different number on both sides, this is actually equal to 30 by 36, that is equal to 5 by 6. Okay, so required probability is equal to 5 by 6. So now let us move to next problem. So in next problem, here we have two dice. Okay, and here two dice are thrown simultaneously, and what is the probability that the sum of the numbers appearing on the dice is 7, okay, and a prime number and 1. So let us see the answer. So here two dice are thrown simultaneously, so the total number of possible outcomes, this is equal to 36, and now let us find the probability of getting sum of numbers appearing on the both sides is 7. Okay, so possible ways are 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Okay, so number of possible ways is equal to 6. So therefore probability of getting sum of the numbers appearing on the dice is 6 by 36, that is equal to 1 by 6. Okay, then sum of the numbers appearing on the dice is a prime number, that is 2, 3, 5, 7, and 11. So the possible ways are 1, 1, 1, 2, 2, 1, 1, 4, 2, 3, 3, 2, 4, 1, 6, 1, 6, 2, 5, 3, 4, 5, 3, 5, 2, 6, 1, 5, 6, and 6, 5. Okay, so number of possible ways is equal to 15, and now the probability getting numbers, sum of the numbers appearing on the dice is a prime number. This is actually equal to 15 by 36, and this is equal to 5 by 12. Okay, so now let us find the probability of getting sum of the numbers appearing on the dice is 1. Okay, so it is not possible, so its probability is actually 0. So now let us move to next problem. So in next problem, here we have two dice, and here two dice are thrown together, and find the probability that the product of the numbers on the top of the dice is 6, 12, and 7. Okay, so let us see the answer. So here the number of total outcomes, this is equal to 36, and when product of the numbers on the top of the dice is 6, then possible ways as 1, 6, 2, 3, 3, 2, and 6, 1. Okay, so number of possible ways, this is equal to 4, and therefore required probability is equal to 4 by 36, that is equal to 1 by 9. Okay, and when product of the numbers on the top of the dice is 12, then possible ways are 2, 6, 3, 4, 4, 3, and 6, 2. So number of possible ways is equal to 4. So therefore required probability is equal to 4 by 36, that is equal to 1 by 9. Okay, and the product of numbers when the top dice cannot be 7, so its probability is 0. Its probability is 0. So let us move to next problem. So in next problem, here we have 2 dice are thrown at the same time and product of the numbers appearing on them is noted. Find the probability that the product is less than 9. So here the number of total outcomes is 36, and when product of numbers appearing on them is less than 9, then possible ways are 1,6, 1,5, 1,4, 1,3, 1,2, 1,1, 2,2, 2,3, 2,4, 3,2, 4,2, 4,1, 3,1, 5,1, 6,1, and 2,1. So number of possible ways is equal to 16. So therefore required probability is 16 by 36, that is equal to 4 by 9. So this is all about this lecture. I stop here this lecture. Thank you very much to all of you.